This course, Data Structures and Algorithms in Python, includes an explanation of various data structures with coding examples, provided with a detailed explanation of code side by side with concept building. Most important data structures like linked list, binary search tree, stack are explained in detail with concepts made easy to understand. Algorithms like selection sort, insertion sort is part of this course. This course is for students who want a good understanding of data structures and algorithms and want to understand code. By taking this course, students will be able to use these skills to write and understand data structures in other languages as well, because concepts built from this course are very generic regarding data structures and algorithms. Students can get this course to understand the algorithms and data structures. This course is not only about writing code, but there are more above code, that is, explanation of working of algorithms. When you understand how it's working, then it's easy to get a grip over algorithms and data structures. Data structures and algorithms in Python. Who this course is for: 1. Students who want to make strong concepts in data structures. 2. Learn algorithms like selection sort and insertion sort. 3. Students who want to learn data structures and algorithms using Python should take this course. What will I learn? 1. Understand arrays and linked lists. 2. Understand stacks and queues. 3. Understand the differences between data structures and abstract data types. 4. Understand tree-like data structures, binary search trees. 5. Understand balances trees, AVL trees and red-black trees. 6. Understand graph traversing, BFS and DFS. 7. Understand shortest path algorithms such as Dijkstra's approach. 8. Understand minimum spanning trees. 9. Be able to develop your own algorithms. 10. Have a good grasp of algorithmic thinking. 11. Be able to detect and correct inefficient code snippets. And the requirements for this course are: 1. Basic knowledge of programming in Python. 2. Some theoretical background, Big O notation.